In this module, we'll be looking at control structures. Before we do that, let's answer this question. What is an algorithm? It's a process or a set of rules to be followed in calculations or other problem-solving operations, especially by computer. So all an algorithm is some steps that go towards solving a problem. Except when we look at programming and computer languages, then these algorithm steps will be applied to a specific programming language. But if we look at this diagram here, we see that we have a series of steps that perform a task, but there seems to be pathways around these series of steps, because sometimes we might want to repeat things or choose between two different things in our program. So this is why we need control structures. Control structures will control this flow between the series of steps that we've created. So here we've got two examples of what a control structure might look like. On the left-hand side, we have a very simple control structure where it's a sequence of steps that just go one after the other. We start at the top, we do step A, step B, step C, and we finish. It's a very sort of simple structure that does three tasks towards solving a problem. Notice that we have a start and an end. Now you might see different names for these, but as long as we say something along the lines of starting at one point and we're finishing at another point, then that's what we're after. On the right hand side, that we can see that this program here, without looking at the particulars of it, has lots of different pathways and lots of things happening. So we have we get to this step here and it asks a question, and based on that question, if it's true, it does this, and if it's false, it goes here. So we can see, and then if we do get the true answer, we have more steps and statements happening here, and more decisions to make, and so on. So it's important that we have a standardized control structures or shapes and words that describe this logic. So here we have the standard symbols that we use for our flowcharts. Very quickly, we have a terminator, the start or the end symbol, it's that oval shape. Processes are in rectangles or squares. Decisions, so anytime the pathway deviates from the main line, we have a decision shape here, so that would be where two paths come from. The input or output symbol describes whether input from the users coming in or output out to the users coming in. And finally, the subprogram symbol, where we stop at our algorithm and then we run a subprogram, which would be another algorithm. And then once that's another algorithm's finished executing, we'll come back to our main program. So we'll look at all these in more detail later on. So let's just look at the two types of algorithms that we can write. We can write flowcharts, or we could write pseudocode. Flowchart is we use symbols and lines to describe the logical steps, whereas pseudocode uses phrases and keywords to describe logical steps. So let's look at sequence. Like I said earlier, sequence is a series of steps that does not deviate, does not choose between different steps. It just goes from the top down to the bottom. So in this case here, we've got get first number, which is saying get some input, because it's an input box, and store it to the first number. Then it says the next step is to get the second number and store it to this variable second number from the user as input. And then we have a process here, so we're doing something. Total equals the first number plus the second number. So that's a process that the computer will execute, and that result of the first number added to the second number we store to total. And then finally we have an output at the bottom here, where it says display, and it says display the sum of your two numbers is, and then the variable total is displayed. Not the word total, the total that's been stored to this variable here. And then we end, that's the end of our program. So that's the flowchart way to represent that. The pseudocode way is very, very similar, except it's using phrases and keywords. So we will notice that begin and end are used to signify the start and the end of our algorithm. And this time we give our algorithm a name. Okay, so this is very important. We'll look at this later on. So this time, this algorithm's been given a name. It's called add two numbers, all one word. And we notice also that we tab in or we indent in. This is not going to do anything other than make it more readable. You'll especially notice this later on when we see more complex control structures. So same logic, we get the first number, we get the second number, so using those keywords to identify that we're getting input and storing it to a variable. The statement is just a statement saying, assignment statement saying add the two numbers together and assign it to total. And then finally, our output, the keyword display has been used, and the sum of your two numbers is the message, and then at the end of it, we just throw that total from the previous step, and we end that algorithm. So I'm just going to stop there. We've been introduced to a lot of things so far, what a control structure is, why we use control structures, and the different symbols and different methods. So the symbols being those flowchart symbols, and we saw there's flowchart and pseudocode, and finally we saw a comparison between a flowchart and pseudocode. There is a part 2 to this video, so you'll have to watch that as well to get the rest of the control structures that we haven't looked at yet.